Hi, it's me, Paula, the math tutor. In this video, we're going to try an exercise, a problem that could be an exam-style problem, kind of what you could expect to find in a IB exam. So let's begin. It says, a six-sided diest die is weighted in such way that the probability of getting a 1 is 7 out of 10. The part A says, the die is tossed 5 times. What is the probability of getting at most 3 ones? If you have some training in doing binomial distribution problems, if you've seen some examples, you'll start to get this sixth sense where you start like smelling that this probably looks like a binomial distribution example. But we have our checklist of 4 characteristics that a variable needs to have in order to be binomially distributed. And then we can use the formula or the function in the calculator. So first, we need to check if the trials are independent. And we assume that they are. Each time you toss the die, it's independent of the previous one. Then we need constant probability. And we have it. We know that the probability of getting a 1 is 7 out of 10. The same one each trial. Then we need it to be binary, either a success or a failure. And yes, we can divide the results that we can get in this die in getting a 1 or not getting a 1. So success and failure. It's binary. And then we need a known number of trials. And we have it. We know that we are going to toss this die 5 times. So the 4 conditions are met, and we are sure that this variable, this discrete random variable, is binomially distributed. X is binomially distributed with 5 trials and a probability of success of 7 over 10. Knowing that, then we can calculate the probability that they were asking us. We can find the probability of getting at most 3 ones. We want the probability of x being less than or equal to 3. And we can either use the formula and calculate the probability of x being equal to 0, plus the probability of x being equal to 1, the probability of x being equal to 2, and the probability of x being equal to 3. But we don't need to do that because we have the function that's called binomial CDF, binomial cumulative. And I'm going to show you how to find it in a TI-84. If you have another calculator, it's probably similar to find. But let's see it with this calculator. So I'm going to show you my screen. Here we are, and we want to go to the section of distributions. Here on top of bars, we have distributions in blue. So I'm going to activate that option with the second key. And now distributions. And now I have a list of a bunch of distributions. I'm gonna go down, and in the option B I have binom CDF. The C stands for cumulative, and this is going to be calculating cumulative binomial probabilities. I'm gonna press enter, and this is going to give me some numbers I need to fill. These are the numbers from a previous exercise I tried, so I'm going to replace them. In this case, the number of trials is 5 again. I'm just going to keep that 5. And now the probability of success, I'm going to clear it, and I'm going to write 7 over 10, or 0.7 if you prefer. And now the x value is 3. And I'm going to paste this. Here I have it. Something you need to remember about binomial CDF, this function in the calculator, is that it's always going to, by default, calculate the probability of less than or equal to the number for x. In this case, that's what I wanted, so that's the only thing I'm going to write. But if I wanted the probability of x being larger than or equal to something, I need to write 1 minus and the probability for x being less than or equal to the previous number. And that's going to give me the probability I'm looking for. But again, in this case, because I wanted the probability for x being less than or equal to 3, the function as it is in the calculator, it's enough. I'm gonna go back to the calculator. Here we go, and let's see what we get. Let's press enter. there we have it. It's 0.47178. Or you can round it if you want. Your calculator may allow you to choose if you want the value for x to be less than or equal or larger than or equal to the number you're writing. But in the case of the TI-84 and many other of the more simple calculators, it's by default this number, so you need to be careful with that and remember that. Now let's go to part B of this problem. It says, the die is tossed 5 times. What is the probability of getting a third one on the 5th toss? There's a lot of things to analyze here before we start calculating. So we know that the die is tossed 5 times. We want to get a 1 on the 5th try, and that one needs to be the third one we got. We need to think of getting the other 2 ones in the first 4 trials, and then take into account that we get a 1 in the 5th try. First, I'm going to calculate the probability of getting 2 ones in 4 tosses. Because this is binomial, I'm going to calculate with 4 trials instead of 5, and the value for x equal to 2. The probability of success is still 7 over 10. I can do it in the calculator with the binomial PDF function, or I can do it with the formula, with the combinations and the exponents and everything. And then, the probability of getting 1 in the 5th trial is just 7 over 10, because it's the probability on that particular trial getting a 1, and they say it's 7 out of 10. So if we put everything together, what we get is the probability, which I can calculate either with the formula or with the binomial PDF function, of getting 2 in 4 trials, 2 ones in 4 trials, times 7 over 10, which is the probability of getting 1 on the 5th trial. If you calculate all of this, you are going to get is 0.18522. That you can also round. And this is it for this example. In the next video, I'm going to try another one. It's a little bit longer and it combines different things from simple probabilities, expected value, and at the end, some binomial situations. Bye guys!